Hi, my name is Elio Damaggio, and this is an overview of a new service called Azure IoT Hub. Azure exposes many services in more than 20 regions. It has infrastructure services and platform services. IoT Hubs is a new service in the analytics and IoT category. Before we start, let's introduce some context. There are other sessions in this conference that are relevant to Azure IoT Hub. The first one is how to build enterprise-grade IoT solutions using Azure IoT Suite. The second one is how to make use of Azure IoT client libraries to connect your devices with Azure. Connecting your devices is the first challenge that you have when you're creating an IoT solution. This is because there is a vast variety of devices that you want to connect. Some of those are internet capable, and in that case, you can connect them directly to an Azure service, for instance, an IoT Hub, or you can use your own cloud protocol gateway in case the device does not use a protocol that is supported by IoT Hub, at this time AMQP or HTTP. Some devices are not capable to access the internet directly, and they work on personal area networks with protocols such as Bluetooth or Zigbee or 6LoWPAN. Those devices need what we call a field gateway to connect to the cloud. These field gateways can do many things, not only connectivity and not only protocol translation, but in this talk we will only refer to them for their protocol translation capabilities. On your application backend side, one of the most important use cases is telemetry. You usually want to have an event processing and insight pipeline, hot and cold paths for people familiar with the Lambda architecture. And an IoT Hub will allow you to get a feed from the device's events very easily. The second big component that IoT solutions have in the cloud is the device business logic. This takes care of the interactive scenarios of your solutions. Think about opening a car from your smartphone, or changing your thermostat temperature, or sending a command to a device to update a piece of firmware. Finally, IoT Hub has to know which devices are allowed to connect and which devices are present in your IoT solution. For this purpose, it has to interact with your application device provisioning and management component, which is the component that makes sure that devices are onboarded and deprovisioned correctly from your own IoT solution. One of the first questions that you might have is why use IoT Hub in the first place? After all, there are services in Azure that allows you to perform the device-to-cloud messaging, for instance, using Service Bus, for instance. IoT Hub, in addition to communication patterns, adds other value propositions to your solution. First, it scales up to millions of simultaneously connected devices. You do not have to scale those services on your own. These communication patterns will scale with you just by increasing the number of units in your IoT Hub deployment. It does support per-device authentication and security. Per-device authentication is fundamental because you want to have fine-grained control on which devices access your solution, and you want to make sure that you're sending the commands to the right devices. This per-device authentication and per-device identity is embedded and designed into the communication pattern in the device-to-cloud messaging and cloud-to-device messaging. There is also service-facing monitoring. IoT solutions usually have the problem that devices cannot be reached without a cloud connection, to connect to a device without a cloud component. Mostly, it requires somebody physically going to the device location and perform maintenance on it. Since this is the case, it is very important to have monitoring on the connectivity status between the device and the service, and to have very detailed monitoring on the status of each and every piece of communication. Finally, IoT Hub supports many IoT protocols and is designed to support constrained devices. Devices that are constrained in networking resources, power resources, or computational resources. Of course, your IoT solution might want to use different communication patterns. Think about uploading or downloading files, or using a real-time proxy strategy, like an HTTP call or a web API. These patterns, while not currently supported in IoT Hub, do benefit from IoT Hub in many ways, and we do provide guidance on how to implement them, taking advantage of many of IoT Hub's advantages. When you provision an IoT Hub from the Azure Management Portal, you will create your own instance of IoT Hub. This instance exposes some device-facing endpoints and some service-facing endpoints. From the device side, each device gets its own unique endpoints. This is for security purposes and for isolation between devices. Each device has an endpoint to send device-to-cloud messaging and to receive cloud-to-device messages. This, of course, field gateways and cloud gateways can connect to multiple of these endpoints at the same time, also using the same TCP connection while reducing resources on those devices. On the service side, your application backend can receive from the device-to-cloud receive endpoint for both your event processing pipeline and also your device business logic for messages such as command replies or alerts that are coming from devices. This device-to-cloud receive endpoints is compatible with event hubs, so any solution that you have that is currently using event hubs will be very easily migrated to use IoT Hub. The device business logic component in your own IoT solution will be making use of the cloud-to-device send endpoint to send messages to individual devices. Each of these messages is very important, and if it doesn't reach the device, it can have implications for your solution. For this reason, IoT Hub has a feedback and monitoring endpoint that provides information on the delivery status of each and every message. In order to create secure connectivity between cloud and devices, IoT Hub has to know which devices are in your solutions and what are the security credentials that they can use in order to connect. For this reason, it has to be integrated with your device provisioning and management component, and it does so by exposing a device identity management endpoint. Finally, there is an IoT Hub management endpoint that is used to change your security and functional parameters of your own IoT Hub instance. Let's look how we can create an IoT Hub using the Azure Management Portal. This is the Azure Management Portal, and let's look how we can create a new IoT Hub. We go in the New section, we select Internet of Things. In here, you can see only IoT Hub, but in production, you're going to see more services in this category. Let's create a new IoT Hub called AzureCon, and we can select a pricing tier. In here, I already have a free one, so I cannot create another free one, but I can create a standard IoT Hub. There are two versions of the standard tier for IoT Hub, and here we're going to select one that allow me to send and receive up to 50,000 messages per day. Of course, this is a single unit. I can, of course, buy up to 200 units with and even more if contacting Microsoft support. 200 units means up to 100,000 simultaneously connected devices and a lot of messages. Let's select this SKU. In here, we're going to just provision a single unit. I can also select how many partitions I want in my device-to-cloud telemetry pipeline. This is similar to the Event Hub partition concept, and it depends on the throughput that you expect in your telemetry stream. Let's select an existing resource group, and let's select a location. While this IoT Hub is being created, we can select another IoT Hub. You're going to see more information when you create your own IoT Hub. In the settings, we can see that there are many sections. The first one is about shared access policies. This pertains to security. you can create up to 20 different shared access policies, and each access policy has different permissions. The registry read and write pertains to the device identity registry endpoint that we talked about before. The service connect permission allows you to receive to device to cloud messaging and to send cloud to device messaging, so as your application backend. And of course, the device connect permission allows you to connect as a device. When we select an existing one, you see that in here I can see the current security keys and the connection strings that I will need to use this shared access policy in my code. There is also a messaging area that is divided in two sections: cloud to device settings and device to cloud settings. In the cloud to device settings, we have two parameters. The first one is the cloud to device time to live. Each message can set its own, but there is one that is defaulted for every cloud to device message, and in this case, I set that to 24 hours. This means that after 24 hours, the IoT Hub will expire a message that has been sent to a device, and optionally, it will send a feedback back to the service. This will allow the service to perform a compensation action for that expiration. The first parameter here, the feedback retention time, is how much this feedback is going to be retained in the system. In this case, is again 24 hours. In the device to cloud settings, I can see the number of partitions. I can have some information on how to connect software that has been expecting to receive from an event hub. And of course, I can set consumer groups. Please refer to our documentation for more information regarding these settings. Of course, I can also change pricing. I can change tier, and I can change unit for my specific IoT hub. We just looked at how to create an IoT Hub in the Azure Management Portal. IoT Hub also provides a vast variety of SDKs, both for devices and for services. There are actually two different flavors of SDKs for IoT Hub. The ones that are device-facing, that are targeted at the devices and field gateways. They support a vast variety of platforms and languages, and we have a specific session that is focused on the client libraries. For service-facing SDKs, they're targeted at application backends and cloud gateways, and they will support many languages: .NET, Java, and Node. Let's look at a sample scenario that will help us familiarize with the IoT Hub functionalities. We're going to have a simulated wind turbine device implemented as a console application that will emit telemetry every second. This telemetry will be about wind speed, output power, torque, and so on. This simulated wind turbine will be able to be started and stopped from the cloud using cloud-to-device messages sent through IoT Hub. The first thing that the sample will do is to provision from a demo portal a device inside IoT Hub. This actually is a two-step process. The portal will create a record for the device in a device registry that is located externally, and then provision an identity for that device inside of IoT Hub. The idea is that the device registry will contain all of the application-specific metadata. Think about the plant where a specific wind turbine is deployed, software versioning, configuration, so on and so forth. The IoT Hub will contain security materials and enable status. Once that security key is available to the simulated device, the simulated device can connect to IoT Hub and starts emitting telemetry. That telemetry will be sent through the device-to-cloud send endpoint and received from the device-to-cloud receive endpoint by an event processor. This event processor can be anything that can read from an event hub. So Azure Stream Analytics, HD Insight Storm, or a custom event processor like we have in this demo. This event processor will take this telemetry message and update the dashboard in the portal. The portal will also be able to send commands to start and stop a wind turbine to the simulated device. These commands will be recorded in a command store and sent to IoT Hub. IoT Hub will deliver the message to the simulated device, which will start the operation and report back the outcome using a device-to-cloud message. The event processor will process this data differently than telemetry messages and will update the command store with the outcome. This is the portal of our demo. This is a portal that is currently running in Azure in a website and is implemented using Web API. In this page, we see that there are already two devices that are provisioned in the system, Turbine 1 and Turbine 2. Let's create a new one. Let's call it Turbine 3 and add this device. What we see happening now is that a new record is being created in document database and a corresponding identity is created in IoT Hub. This page is actually driven from the data in the document database. So all of this metadata, model, plan, telemetry component version, and command history is all coming from document database. In the only moment when a sample portal contacts IoT Hub is to retrieve the key. This key has been generated by IoT Hub, but you can also provide your own for your devices. Now let's connect a simulated device. We have here a console app that is simulating a device. Let's copy this key and start the simulator. We see here that every second there is a new telemetry message that is being sent. And in the portal, we can go in the telemetry dashboard and see the data updating in real time. What is happening is that device is contacting our IoT Hub. The events are being received by our event processor host that is then contacting the dashboard to update it. Now let's see what happens if we send a command to stop this turbine. In here for Turbine 3, I want to send my stop command. What happens is that the command is being received by the simulated device. A record is being created in my command store. And of course, the telemetry reflects the fact that the turbine is now stopping. Once it reaches 0, and it sends the acknowledgement back to the application backend, which then can update the command store and update this portal here. Now, let's start this turbine again. And of course, this will not be very interesting if we could do this only with one device. IoT Hub supports millions of simultaneously connected devices. And in here, I will start another simulated device and show how the telemetry gets displayed and it is flowing through the same pipeline as before. Let's look now at the code to implement this demo. This is a class called Device Manager, which is the code that is behind the list of devices that we just showed. There is a method here that's called Provision Device, and we see that effectively the only two things that are happening is the insertion of an entry in the document database and the creation of a new identity inside of IoT Hub. This is done very easily with the IoT Hub service SDKs using a registry manager. In this case, we have a registry manager. We call the add device method, and we put as a parameter a new device with a new device ID that in our case was Turbine 3, and we just set the status as enabled. That's because we want the device to be able to connect right away. There are cases where in your provisioning workflow, you might want to create a device in a disabled state and then enable it later. In here, you see that I'm not setting any new key because IoT Hub will auto-generate keys for you, but you're free to generate your own with a certain minimum length. Now let's look at the simulator. The simulator has three main components. The first is a simulation loop, which just creates simulated values for wind speed, torque, and output power. Then there are two other components, one that sends telemetry every second, and then one that is receiving the commands. The send telemetry, it's really, really easy. It creates a new telemetry message with all the data from the state that is generated by the simulation loop. And then it creates a new message, and then it calls the device client send event method. The device client is part of the IoT Hub device SDK for C#. In here, we see how it can be created using the IoT Hub hostname and an authentication method that contains the turbine ID and the turbine key. We do offer many ways to authenticate, and we will offer more going forward. When you receive events from the cloud, you can use any way, any method that is compatible with event hubs. In this case, I'm using an event processor host. An event processor host is hosted, in this case, in a web job inside my web application, and it's implemented as a very, very simple application that is processing events, and for each event, it just discriminates telemetry messages from command response with the presence of a correlation ID property on the message. If it contains a correlation ID, it is assumed to be a command outcome. Otherwise, it is assumed to be a telemetry message. Of course, you're free to create your own categorization logic and your own event processor using any Azure service such as Stream Analytics or Azure Storm or HD Insight Storm. What this very simple process is doing, it is discriminating events that are commands outcome from the ones that are telemetry, and it's using a system property called correlation ID to do that. You're, of course, free to create your own categorization method. When you want to send commands, it is, again, very straightforward. Here, the portal is, again, doing something very similar to the provisioning. It is updating the command store in document database, and then it's sending a command using IoT Hub. In this case, we're using the service client class from the Azure IoT Hub SDK. To send a message, a new message is created and is sent to a specific device ID. The simulator, in order to receive a message, is calling a method called receive async, and it does that in our receive loop. It is called a loop because the receive async method will return every time a new message is received, or after a certain timeout is expired. In this case, I have a timeout of 5 minutes, and if that happens, the receive command is null. You have then a chance to effectively regain control of your application and do something else. In this case, if the command is null, I just call it again because I want to have I want to always be receiving messages from my IoT Hub. Once I receive the message, this is just a simple byte array. I will deserialize a JSON and then perform my command logic. This was a very simple tour of our sample scenario, which illustrates the main capabilities of Azure IoT Hub. Azure IoT Hub supports millions of simultaneously connected devices. It supports per-device authentication and per-device identities, which makes sure that your device connectivity is secure. It does support high-throughput device-to-cloud messaging and reliable cloud-to-device messaging, and it has extensive support on the device and service SDKs. You can try Azure IoT Hub for free now on azure.com. Thanks for watching.